Hello, my name is Enrique Guardado, and this is my GameVault API project for Week 3, Part 1. This API performs CRUD operations on a MongoDB database with validation and error handling. Let me show you the GitHub repository where all the code is hosted. As you can see, the .env file is not included in the repository to protect sensitive information. Now let me show you the MongoDB database in action. I created a brand new database called GameVault_DBD, which contains two main collections, games and players. The games collection is quite detailed, having 8 specific fields including title, genre, platform, release year, developer, publisher, rating, and is completed. On the other hand, the players collection has 5 fields. Right here you can see an actual game document that was successfully created through our API. The application is fully deployed on Render and is accessible at this public URL. It is important to note that it is not running on my local machine or local host. All the environment variables, including the sensitive MongoDB connection string, are configured securely inside Render's dashboard and are absolutely not exposed anywhere in the GitHub repository. The API includes professional Swagger documentation that can be tested directly from your browser. As you can see on the screen, the server is correctly configured to use the live render production URL. We have comprehensive endpoints available for both the games and players collections, fully covering get, post, put, and delete operations. Let me demonstrate the full CRUD operations, starting with creating a new game. I will use the post endpoint and send valid data, including all the required fields like title, genre, platform, and rating. Now let's retrieve all the games in our database using the get endpoint. As you can see, the response code is 200 OK, and it returns the complete list of games, including the new one we just created. I can also fetch a specific game by its unique identifier. I will paste the ID of the game we just created, Super Mario, and execute the request to get its specific details. Next, I will update this game's rating and its completion status using the PUT endpoint. This action will permanently modify the existing document in our MongoDB database. Finally, to complete the CRUD cycle, I can delete this game using the delete endpoint. I will provide the same ID, execute the request, and we will see a successful deletion message. To be absolutely sure, let me switch over to MongoDB Atlas and refresh the games collection. You can see that Super Mario has been successfully deleted, and only The Legend of Zelda remains, with its newly updated rating. Now let's test the players collection to ensure our API handles multiple entities correctly. First, I will create a new player with valid data, including their name, email, and favorite game, using the post endpoint. After executing the request, we get a 201 created status along with the new player's unique ID. Next, I will retrieve all players using the get endpoint to confirm this new record was successfully saved in the database. Finally, I will update this specific player's information using the put endpoint, modifying their email address to a new one, and we get a successful 200 OK response confirming the update was applied. Now let me demonstrate the data validation features of our API. Both the post and put routes strictly validate the incoming data and will return 400 errors if the requirements are not met. First, I will try to create a game with invalid data. I am sending a rating of 15, which exceeds the maximum allowed value of 10, and I am also intentionally missing the required genre field. The API correctly catches this and returns a 400 bad request error, detailing exactly what went wrong. Similarly, if I try to update a player with an invalid email format, it will also return a 400 validation error, keeping our database clean and secure. Each route in this API uses robust error handling with try-catch blocks to prevent server crashes. Let me demonstrate this by trying to get a game using an invalid MongoDB ID format. I will type invalid123 in the ID field and execute the request. As you can see, the error is caught and handled properly by the application, returning an appropriate status code instead of breaking the server. Finally, let me confirm the deployment requirements. The application is fully working at this published render link, and it is absolutely not running on localhost. And as I showed earlier, sensitive information like the MongoDB connection string is not present in the GitHub repository. It is only configured securely inside render's environment variables. This completes my GameVault API project. It includes full CRUD operations, data validation, error handling, Swagger documentation, and successful deployment on render. Thank you for watching.